Alright guys, here we are taking a look at this practice 2.2.3, recognizing average rate of change, and this is the A version, whereas the other one was the B. So the following graph shows the amount of paint needed to paint the trim molding of a house as a function of the length of trim to be painted. Use the graph to answer question 1 and 2. So we're finding that rate of change, which in a linear equation like this one is essentially its slope. Okay, now they've told us they want us to look at this interval of 150 to 500. So 150 is about right there, probably at 0.2 we'd call that. 150.2, right, would be the point. And we're going to 500. 500 would be up here, looks to be about 500 and 0.7. So our slope, right, is that horizontal change and that vertical change. That change in y over the change in x. So the difference from 150 to 500 would be 350, right? So that's what goes on the bottom of our fraction. Okay, and then from 0.2 to 0.7 would be 0.5, wouldn't it? So I'd go 0.5 divided by 350. Which gives us about 0.00142857, which means that for every 1 foot of trim, that's how much of a gallon of paint you will need, which trim is pretty small. Okay. So number 2 then wants the approximate rate of change from 900 to 1300. Okay. So from 900 would be right here. Okay, we could estimate that at about 1.3, so 900, comma 1.3. Then to 1300 would be up here. That one's not quite 1.9, maybe 1.85. So it would be 1300 to 1.85. So again, we find those differences. Okay, so the top would be 1.85 minus 1.3 over the 1300 minus 900. So it ended up being 1.85 minus 1.3, would be about 0.55 over the 1300 minus 900 would be 400. So 0.55 divided by 400 would be about 0.001375, which is pretty close considering we estimated our numbers pretty close to the same, which in a linear equation that's what we expect. Okay. Alright, now let's take a look at another one. So again, same idea. We've got a linear equation, value of the euro versus value of the dollar. We want to find the approximate rate of change from the interval of 10 to 20 for number 3, and then 40 to 55. Okay, and then talk about what if we did a third interval. Okay, so that looks about halfway between. So the bottom here on number 3, right, 20 minus 10. The top looks to be 15 minus, I would probably say 7.5, because it looks like it's almost exactly halfway between 5 and 10. Okay, so we'd end up with 7.5 over 10. Which would give us 0.75. Okay, so for every dollar, that's about 0.75 of the euro according to this graph. Okay, which we should get that pretty much that same idea here on these other ones. So we've got the 55 there and the 40 right there. So 40 might be 31 for the y value. So we'd go 55 minus 40. So we'd get 15 for the bottom. And maybe 31 and 43. So that'd be 12. Which if we go 12 divided by 15, that would get us 0.8, which 0.75 could round up to 0.8. So what would we predict? We'd predict something around that lines for any third interval. Because it's a linear equation, we know it's going to come up with a similar number. Alright, now let's take a look. Now this one we can see that it's curved slightly, so we've got an exponential here. So each year, employees at a wildlife park record the total number of visitors to the park over Labor Day weekend. The following graph shows the number of visitors for each of the last 10 years. Use the graph to answer questions 6 and 7. So again, we're just looking at intervals and trying to decide what that slope is. Now, because it's exponential, it's not going to be the same all the way across the board. Okay, that's the main thing we have to understand. So I go to 2 to 6. So 2, call that 500 even, right? 2 to 500. Okay, then 6. Well, that's nice. We'll call that 600. That's a pretty easy one, right? So 600. So that horizontal change would be 6 minus 2 or 4. Okay, easy. 1, 2, 3, 4. And then a vertical change of 6 to 600 minus 500 or 100. So it would be 100 over 4, which is 25. So every year we're averaging 25 more visitors than the last year, kind of thing. Okay. And then it wants 2 to 9. So going 2 to 9, 2 same place here, and we're going clear out to 9, which is at 700. So again, 9 minus 2, we'd have that horizontal change of 7, and that vertical change, 700 to 500, would be 200. So I'd have 200 divided by 7, which when I type that in to my calculator, we get about 28.57. So can't really have partial of a person, but roughly we'd average about 28.5 people more per year. Okay? Alright, last graph. So we've got the population of a town in years. Looks like it's decreasing, going down. So again, we just find those intervals, 2 to 9. So 2, we've got our graph up there. It's not quite 9,000. Goes up by 1,000, so maybe it's 8,900. So 2, 8,900. And then we're going to 9. That one's slightly above, so maybe 9,700, we'll say. Okay, so again, that rise over run. So we're going down. So it's going to be a negative average rate of change, isn't it? Okay, so I'd go 7,100 minus 8,900 to give us a negative 1,800 on the top. That negative just means it's decreasing, not increasing. And then 9 to 2, 9 minus 2 would give us 7. So divided by 7. Would give us about 257.14. So every year we're losing about 257 people. Okay, then we do 14 to 20. Okay, so 14 right here, that looks like that's right at 6,000, so 14 and 6,000. And then 20, looks like it's right at 5,000, so 25,000. So that's going to be pretty easy because we can see we're going down by 1,000, aren't we? Okay, so my change in y is 1,000 over 14 to 20 is 6. So we go 1,000 divided by 6. We get about 166.6 repeated. So almost 167 people per year that we're losing in this town. So now, how do they differ from each interval? For each interval? Well, they're different numbers, aren't they? Okay, quite a bit different actually. And so notice that as we get further on the interval on the right, our numbers are getting smaller because of how it's growing. And there we go, guys. So that's all we got here for this one. So if you want some more examples, you can watch the other video as well.